So guys, welcome back to our channel. So today Gate 2024 CS paper is being conducted. So we are discussing the first part of the first set of the check question. So where we discuss the memory based question. So in DBMS we get the six question. The about six question, four question is getting 1 mark, and two question about 2 marks. Total six question is came, and total 8 marks in asked in DBMS. So we are discussing the six question serially. So we came up the first question. So this is related to the closure property, closure property or functional dependencies question. So this is a MSQ question. Okay, so this is a MSQ question. So we have to find out which one is implied. So if x derives y and y derives z, then implies x derives z. So in x derives y and y derives z, in the transition property, transition property, this is a transition property that x derives y is also being implemented. So this is a correct statement. Also we have to check the closure of x. So if we need the closure of x, it gives x derives y, so we implement y, and y derives z, so z. So for this closure we get z, so this implies z is true. So then if we say that xy derives z and y derives y, then it implements that xw derives z. So if we take closure of xw, so we get xw, from w we get, from the w we get y, and xy we get z. So from the closure of this we get z. So this option is being also satisfied. So then third, xy derives zw, then implements xy derives z. So xy closure, if we find out the closure of xy, so we get xy, and xy closure is zw, so also we get z. So this also being implied. And option D we get x closure. So if we xy derives zw, so which implies x derives hzw, so you get that x closure, so we get only x, and here we get xw, but here we not get y, so we are not getting further anymore. So this option is being no. So the answer of the given MSQ question is option A, option B, and option C. So there is another question related to the B plus tree. So the minimum fill factor of 50% is not necessary for, not necessarily fill. So which of the root node, internal node, depth substrate node, or leaf node? So if we get that the order is n, if we take that order is n, so maximally we get n pointer, and we get n minus 1 keys, and minimum, so we get seal value of n by 2, and pointer is n by 2, seal value minus 1 key. So if we if we firstly derived any node, so from that we get if the one key is value is present, so we get one left pointer and right pointer. So this is not all timely full. So the answer of the given question is root node. So root node is not evenly full, all the time is filled. So the answer of the given question is root node. So now we came upon a relation algebra question. So there is a two table is being given. So we have to find out the number of the tuples of the output of the following relation algebra. We have to find that the R joined S with respect to A, and we have to apply that the condition B is less than C. So here the table is being given. So we, if we apply the join, so we get the table. So R joined S, and we get the table contain the three tuple ABC. So from that RD is equal to SA. So from here we get that 10, 20, 10, 30 and 40 is being present. So this will be mapped with this. 20 is being not matched. 30, this 30 is being matching with, this 30 is being matched with, and this 40 is being not matching with each other, and here is being this 30, 50 is not matched with each other. So we get 10, 20 and 30. Also we get 30, 40, 30, 40 and 45, and last we get 30, 50, 45. From here, from the relation we get SS derives Sato, so R cross A. So if we apply the condition that B is less than C, so B is less than C satisfy this condition, so we get one tuple A, one row, and also these conditions we get one the set condition is being satisfied, so we also taking this row as, but here b is greater c, so we are not taking this. So from this we have to get the two row as a output, that 10, 20, 30, 30, 40 and 45. So we get two tuples or two rows. So number of tuples or number of rows. So we get two rows. So answer of the given question is 2. So we came up with another question related to the transaction. So the question is came upon transaction. So we have to find out the following schedule, which the thread schedule. So the transaction is being given. So which one is being the conflict equivalent? So we have to find out the conflict equivalent pairing. So there is a three schedules. So we have to draw this way. So T1, T2, and T3. So R1Z. So R1Z, W1Z. So W1Z, R1X, R2X, R3Y, R3 of Y, W3 of Y, W3 of Y. Then we get R2 of Y, W2 of X, W2 of Y. So we have to find out. So we have to draw the, for this we have to draw the precedence graph. Precedence graph. So we have to draw the precedent graph. So we have to, the number of transaction 3. So we have to draw 3 nodes. So we have to draw the 3 nodes. So from here R2Z, we have to nothing z, z here from the T2 and T3, so not conflict with each other. W2 is z, not conflict with each other. Rx, R1, R2x, R1 means Rx is nothing conflict with each other. So from internally T2, T2, so not conflict. So Ry is conflict with T3 of Y. So T3 to T2, T3 to T2 is conflict, and then W2 is also conflict. So this is being getting out. W2 is conflict. So we get that T3 is conflicting with T2. Any other not conflict. So for the finding that the number of which is the scheduling number, so we have to find out using the topological sort. Topological sort. So we have to perform the topological sort. So for the topological sort, we have to find out that the node which which degree is degree is 1, in degree is 1. So if we find that the degree is 1 is two vertices 1 and 3, so we have to choose these two, 1 and 3. So from 1 we have to choose only 3, because 3 is dependent upon through. So 1, 3, 2. We're not taking 2 as, because when completed 3 we have to go to 2. If we take 3, then we remove this edge. So from we take two option, we can only take 1 then 2, or we can also take 2 then 1, because 2, 1 and 2 are then in degree is equal to 0, in degree is 1. So that's why, so the possible outcome is 1, 3, 2, 3, 1, 2, 3, 2, 1. So from this option 1, 3, 2 is being correct. So this is being option 1, 2, 3. 1, 2, 3 is not being accepted, because 2 is the 3 is the dependent upon 2. So when completing 3 we have to apply the 2, so not taken. 3, 1, 2 we have to take. 3, 2, 1 we have to correct this option. So the answer of this question is C A, C, and D is the correct answer of this given question. So we get the next question related to the year diagram. So we have to follow represent that the year diagram. So student register for courses. So we have to draw the student is an entity to a student register. This is a relation register. So student register for courses. Courses is also being an entity courses. Then courses allocates classroom. So courses is being the entity is being present. Courses is a relation to is allocated classroom. Classroom is also an entity classroom. So courses allocated classroom. Then instructor guides student. So instructor is in one entity. Instructor instructor की the relation is guide. Instructor guide student. This is relation. Instructor teaches courses. So instructor, the relation is teaches and courses. So this is the correct tier diagram of the given question. So this is one of the answer of the question given present. So this all the DBMS question. Thanks for watching. If you need this type of content, please like, share, subscribe to our channel.